All right, I think we're about ready to get started here. Hello, my name is Scott Friend. I'm the president of the CFTA, and I would like to welcome everyone to this month's webinar series on University of Washington's GIS Interior Space Mapping with speaker Aaron Cheuvront from the University of Washington. I will turn it over to Aaron.
So this presentation is going to go over a fairly high-level overview of what we have. And let me start the. Yep. Okay. So talking a little bit about the history of CAD and GIS for the University of Washington, where we're at and where we were. Talk a little bit about the way that we prepare the CAD drawings to provide a very nice integration with GIS. And this is done in both the floor plan environment as well as the BaseMap environment. Looking at the different ways we do the translation, because we do have a very different process for floor plan translation than we do for the BaseMap. The BaseMap is semi-automated, but we're actually going to be automating that hopefully in the near future. Then look at the utilization of floor plans in GIS. You know, what can you do with it? What's the point? You know, it's definitely not an easy thing to get thousands of CAD drawings into GIS and maintain those and keep everything synchronized. But is there even a value in doing that? And I think that there definitely is, and I think it can play in really well with a lot of other systems that are out there, not necessarily replacing things, but augmenting different systems to really get you, you know, things that you never could before. And then, you know, what's next? What are we planning on? What are we thinking about? And where we go from where we're at. So in the past, the original version of GIS floor plans was not georeferenced. It was basically everything laid out in a grid for the floor plans, so you could see the whole building at once. It was primarily for analysis of visual analysis using thematic mapping of looking at the whole building, you know, and doing thematic mapping by room type or department, that kind of thing. And one of the biggest challenges we had was that the CAD drawings really weren't standardized. There wasn't a really well-maintained standard that everything was maintained at. The standards had evolved over time, and it was nearly impossible to go back and change the old drawings to the new standard. So it was, when we did our conversion with the version 2, we actually found some of the old CAD drawings that had upwards of 3 or 4 different standards within one drawing because they didn't have time to go back and fix everything from history. The translation was very manual. It was basically exporting a shapefile out of CAD using a variety of different tools and then importing that one shapefile into a spatial database engine using Oracle. Where we're at now, we're actually in a pretty good place now. We've gone through and standardized everything. We've also georeferenced all of the floor plans, and we do georeferencing differently than a lot of other places may, and it's all from a CAD user perspective because our CAD users are actually the ones that are maintaining all of the data, and the nice thing about the way we have things set up is that they don't actually need to know anything about GIS at all. So we do have all of our CAD drawings very, very well standardized, and because we have a common standard now, we can always go back through history and just write a batch script to do, you know, change this to this in every single drawing. And it'll take it like 3 or 4 days to run, but it'll actually do everything at once and keep everything nice and standardized. So our translation is fully automated. We look for changes, the server looks for changes every hour, and if it finds a drawing that has been updated, it'll automatically process that, and if everything goes well, we're good to go. If not, it'll report an error, and then the CAD user can go fix the error and then try it again. So from a drawing preparation perspective, you know, one of the questions I get frequently is, what does the process look like from the CAD users? You know, the people that are actually going to be updating the system, what does their daily life look like? And it's actually very, very simple. You know, starting with a whatever update, whether it's a project, whether it's, you know, our facilities alterations department going out and putting in a door or taking out a wall or whatever it is, there's some form of documentation, hopefully, that would initiate a change to the floor plan. The real process is basically the CAD user checks out the drawing from the document management system. They do whatever updates need to be done. What I've done is I've written a custom set of code in CAD using lists so that when they save the drawing, it'll automatically do everything necessary for GIS to be ready, and it'll do the error checking. And then it'll report errors if there are any. Otherwise, it'll say everything's good and continue on your business. So once they check in the CAD drawing, then we have a possibility with the document management to either, depending on who the CAD user is, either just fully release it and it's good to go, or it has to go through a QA process, and one of the higher level CAD users has to go through and look at it and make sure everything's good, and then they'll actually release the drawing. And that's it. From the CAD perspective, that is the daily world. That's how everything works. So it sounds fairly simplistic, but it's only because things have been standardized and we've come up with a very consistent way of doing things. Really, everything is built off of creating a link between a room number, in our case, a block with attributes, and the actual room polyline. That's the real primary data that we're going after. We also do some other layers of information. But it's the room number that really is the critical component. And a traditional GIS process would do some sort of a spatial intersection to find, the room inside of the polygon, or the room number inside of the polygon, and then link the data based on that. But it's not very reliable from a CAD user perspective, because from a graphic point of view, the room number doesn't always fit inside the room. And as soon as you don't have the room number inside the room, that whole process just doesn't work anymore. So we've actually come up with a way of creating a very stable link in CAD that is a pure, raw, vanilla, out-of-the-box CAD tool. And it's basically using a field instead of typing in a value. And one of the things I really like about this is that instead of having to go through and type in square footage so that we can display the square footage in CAD, I can have that link directly to the polyline. So as soon as the polyline is updated, the square footage is updated, which means there's no possibility of somebody, putting in a typo, and instead of having 114 square feet in this example, it's 411 square feet or something like that. So it's eliminated an entire step of managing the CAD drawing by using a linked field in order to get that data. So, and it's really simple enough that all you have to do is right-click in any text or attribute value field and select Insert Field, and this window on the left is what or in the middle is what you'll get. You can do this manually. I have a script that does this automatically, which works really easy for us, but to do it manually, you want to change the field category to objects, and then the field name to object, and then there's a little button right here for select objects, and you go and pick the room polyline that should be linked with your room number. And then you can do, what kind of format do you want, and then additional formatting. For the conversion factor, we want square feet, not square inches. And I actually put in 1/144, and then it automatically converts it to a decimal as far as it can go out. And you can do suffixes and prefixes and however you want it to look, but it really doesn't matter. The real key to it is the text may show the square footage as well as the prefix and suffix, but the actual field expression, the back end side of things, actually stores what it calls an object ID number. And this is different than a handle. And it's very important to know that, because handles really aren't very stable. The object IDs are unbelievably stable. It actually allows us to copy a room boundary and a room block with a room number together, and the new instance of that will actually be linked together correctly. And so all we have to do is change the room number, for example. I don't have no idea how it works, but somebody at Autodesk is a genius, because this thing is unbelievably stable. You can even copy the room boundary and the room text to a different drawing, and it'll still stay linked. So once we have that object ID number, that provides the link between the text that has all our data that we want to the polyline that has the shape that we want. And that's really what GIS is looking for. It's looking for a shape with data. And that link is what allows me to take the data from the block and write that to the polyline using Arcgis for AutoCAD. So using Arcgis for AutoCAD, there used to be a really nice API. They've changed things. I have to rewrite some of my code. But it will take all of the data that's in the text block and convert that into data on the object itself. And so down here you can see, this room selected. It has all the information that I'm going to need in GIS already assigned to the polyline before GIS even looks at it. So when it comes time for GIS to do the translation, it doesn't have to do any processing to try and transfer data. The data is already there. So that's the floor plan side of things. Our BaseMap side is quite a bit different. We did this after we did the floor plan process, and we wanted to come up with something that was a little more configurable. So what we put together was a configuration file that it just lives in Excel and allows us to describe everything about the CAD world and the GIS world as a very simple configuration that CAD and GIS can read and do what it needs to do based on that configuration. So if I want to create a new base map for a new campus, for example, if I have the geometry already done, I could have the whole thing up and running in probably 10-15 minutes, because all I have to do is put in, what drawing is it, what feature class do I want, what kind of feature class is it? Is it polygon or point or whatever? Where's the data coming from? Is there a unique ID? All kinds of other variables. And the variables that are in here actually control the error checking. And actually, I think I bypassed that before. But in the room, in the floor plan world, error checking is absolutely critical. We do tons and tons of error checking in CAD before GIS ever looks at it, because otherwise GIS is going to report an error, which then the CAD person has to go back and fix. Why not do the error checking in CAD? So this is an example where we have one room boundary that is linked up to two different room blocks. And so, one of these is wrong and needs to be fixed. And it's a fairly straightforward process of doing that. For the BaseMap world, the error checks that are run depend on the configuration. So with the rooms, we check to make sure that all the room numbers are unique. But for the BaseMap, not all of the layers or feature classes will have a field that has a unique ID. But if it does, we can identify which field of data has a unique ID, and it'll do a uniqueness check on that ID field inside of CAD and report any errors if it finds it. Very, very brief explanation, but we'll see what we can do. So the next big thing is, okay, we have a base map in a normal georeference coordinate system. Our floor plans, however, use a local building coordinate system. So lower left is either the corner of the building or the column grid intersection, if there is a column gridded setup. We actually create the world files from CAD instead of using ArcMap or anything like that. The way it works, and this is actually something that I had found out about through another CFTA webinar like 2 years ago. And I can't remember who it was that showed this. But it was basically, a world file is just two pairs of coordinates of, before and after. And by taking your floor plan and inserting it or XREFing it or whatever into your site plan, you can easily calculate the coordinates for the before and after and write a text file, which is a world file, very, very easily. One of the easiest things to do is to calculate the first coordinate pair, because whatever 0, 0 is in the floor plan is the same thing as the insertion point in the world file. So here's a look at here's the information we have from the properties in CAD, and down below the actual world file itself. So our floor plan origin is 0, 0, and here's the X and Y of the insertion of that floor plan into the site plan. And it's been scaled and it's been rotated and all kinds of other stuff. So we can use any random point. And in this case, I tend to use just 1000, 1000. and then I can calculate what that fourth final point is based on the scale, rotation, and everything else. And I have a set of Lisp code that does that. I'm actually going to be releasing that to the public here shortly. I'm hoping to package that up along with a couple other things and post up on the ESRI website in their map gallery or whatever it is, maps and apps. It's just a really nice way of doing it. It's very simple, very straightforward, and the process is basically run the command, pick whatever your floor plan is that's inserted, and it'll ask you where you want to save the world file, and it's done. Another piece that will be with that is calculating the rotation angle of what the floor plan is when it's geo-referenced, so it can be used inversely to rotate the floor plan back to what CAD had it as in a GIS world. And I'll show you that at the end, but it's very useful. So from a server side, when it comes to translation, what actually happens? It really starts with the document. There's a window schedule task that runs every hour. The first step of it is the document management system that controls, all of our drawings. We use Autodesk Vault, and there is a free application called Vault Mirror, which is really great. It is able to run whenever you want, and it will download whatever drawings have changed since the last time it checked for changes. And since we do this every hour, it basically looks every hour for changes. The way we have it set up is that there is a specific user that is doing that interrogation of the system to see if it is a drawing that's supposed to be used in GIS. And so we have different categories for different files. So the floor plans are those are GIS, as well as the world files. But we have like Revit files that we're not doing a direct translation yet. So those don't get downloaded. So the process starts off with, well, are there any drawings? In the middle of the night, there aren't. So it's not going to do much. So it just stops. But when it does find drawings, it processes each drawing individually. And it's fairly important because of the way the whole thing works, that we can process one drawing, and if that one drawing has a problem, that one's kicked out, and it doesn't affect anything else. So the first step is to create the version, and creating a version allows us to propose changes essentially without actually affecting anything. We have our own history system set up, so we copy what's in the real system into history, date stamp it so we can always see what's been changed in the past. And then we go back to the real system and actually delete that entire floor plan from the production system in the version. Once that is cleaned up and there's nothing in there for that floor plan, we use an FME process to load the CAD drawing with all the feature classes that are pre-built with all the data. And it's more or less a feature class to feature class translation. We do some interesting little things here and there in FME. That loads it all into the version. And so that's our now proposed change. Once that's done, it does some error checking, and if there are any errors found, it'll actually just delete the version, which means it just cancels everything, and it doesn't make any changes whatsoever. It restores everything back to what it was before it started. If there aren't any errors, then it'll reconcile and post those changes to default, and now the floor plan is updated, and then it goes through and deletes the version. Either way, we always delete whatever CAD file was being processed, because if it had errors, we don't want to process it again. And if it succeeded, we don't want to process it again, so we delete the file. If it changes, the next hourly process will see that it changed, download it, and reprocess it. And so it just loops around until it finds no other drawings, and then it stops. And it really runs on its own. I think we only have it running during the day, but it works fairly well. So for our FME translation process, this was built by Steve Grisey with Vertex 3. And we came up with some really interesting ways of making this work. The left side here is actually reading the CAD drawing, and it has we have 3 feature classes that are coming out of this, and the fourth one actually just goes out and says if there's anything else in there, then it shouldn't be in there, it writes an error. But it's basically looking for our rooms, our GSF boundary for the floor, and then the architectural lines. And in the architectural lines, we actually have two different versions of those. One that's just everything exactly as it is, and then one that's sort of streamlined that makes things run really, really fast. And all three of these, all throughout the translation process, it will look for certain key things, and if it finds errors, it'll just report that to the error system. And then once this is done, it'll look and say, okay, were there any errors? And if there were errors, it'll just cancel the whole thing and move on. So the error tables that we have two different logs. We have a processing log, which just says, you know, we processed a drawing and what it was that was done. And then we have an error log. If there were errors, then it'll write to the error log. And I just looked at the processing log yesterday, and I think it goes back to April of 2011, and we have what, 5,900 floor plans that have been processed. So a lot of these are changed, you know, the same floor plan over and over again. But you know, 6,000 drawings over the last couple of years that are just fully automated for the translation. For our error log, I actually dumped this at the first of the year because we did some changes to the code that made it a lot more reliable. And what's interesting about this is there was actually a problem with one of the CAD users who didn't have the tool set up in CAD to actually prepare the drawing for GIS. So most of these are just because they didn't have the tool loaded and tried to process it without the drawing being prepared right. Beyond that, there's actually only 2 errors that have occurred, and one is like 4 times it tried to process the same drawing, and I think most of this was me trying to figure out what was wrong with this one drawing. So, you know, really only 2 errors in the last, you know, almost 6 months now. It's very, very reliable. So our tool for the BaseMap, this is it's actually pure Python, the way it works. And Steve put together a toolbox for us that has a load, and then it has a QA/QC process. And it's really amazingly useful. It will actually read the same configuration file that CAD does, and it can build the entire feature class if needed. If we create a new feature class in CAD through the configuration file, this script will automatically create the feature class in GIS so it has something to put it into. And so this does a similar process where it puts it into a version, and then we can review that and do some quality control. And if there's a problem, we fix the drawing and we run it. If it's all good, we basically the QA/QC approved basically just reconciles and posts the version and then deletes the version. So it's fairly straightforward. The inputs on the tool basically just say, what campus do you want? And the campus relates to the folders for the different campuses that we have, and it'll just go in that and process. The base app also has its own set of logs. These are actually refreshed every time the tool is run. Because it is a manually run tool, we don't really need to have the history of everything that's ever been done in the past. And all of the errors that would have been there before would be overwritten by whatever we're doing now anyway. So we don't really need to keep the history of that. So before and after translation, you know, the left side here is our CAD world with our site plan and our CAD floor plan, and then the GIS version of that, and it's pretty much the same thing. So looking at the utilization side of things, you know, what can you do with it, and what have we done with it? We started off with a Flex application, and we actually developed this at the same time that ESRI was building their Campus Place Finder. And so I think they got theirs out just before we did, and I was really upset because I could have just used theirs and been happy, mostly. So we have our own floor plan viewer in Flex. We've also been doing some interesting work with JavaScript. And this is a simple application that we put together for the CPO department for doing for looking at the directory of people. And so we can find somebody and see, you know, are they in a meeting? What's going on? What's their phone number? And then the recent addition is the map. Where are they located? And so it's an interactive JavaScript map. And the nice thing about this is that it actually runs on a mobile application, unlike the Flex app, because of the whole Flash issue. And I've used this actually quite often out and about, being able to just look at a floor plan on my phone wherever I am. So I think the big one becomes asset management. The floor plans with space management is pretty much the standard thing that you would do with GIS floor plans, doing thematic mapping, space utilization, all kinds of fun stuff like that. But what we're finding is that we can actually do an incredible amount with managing every possible asset in a building with GIS through a combination of a couple of different processes. Because we have our CAD to GIS translation process so well defined, we can actually piggyback on that. And so if somebody else is doing a different set of CAD drawings, we can translate those into GIS the same way, and everything lines up. Or we could do a one-time batch import from, say, a project or something like that. Most of this data that you're seeing here actually came from a Revit model for a pilot project we were doing with Kobe, and trying to get the data from the project out of the model and be able to put it into the asset management system. And the hope was that we would be able to use Revit or something like that to recombine the data with the graphical assets in a 3D world, and be able to click on the asset and see all the data coming from the CMMS system. But it just didn't really work. Revit has some limitations in being able to do that, and you're pretty limited in essentially volume. I mean, you can't really load every single building everywhere that you have and expect Revit to not explode. But with GIS, I mean, that's just the way it works. So we were able to build a really nice link to the live asset management system to bring in the data about the assets, and GIS just has the graphical location and the asset ID number that ties back in with the asset management system. So you can select an object and see all the data about it, but the data is actually managed by the asset management system. So again, we're not trying to take over anything. GIS really probably isn't the best way to try and do asset management in a large facility environment, but it's a great way to visualize things. So this is a close-up look at some of the information. The lines that are on here are actually the HVAC system, and this we actually did something different where we simplified the duct work, because what we found was the realism of BIM wasn't particularly useful. I mean, it was important to know that, yeah, there's a duct running about here and where it branches off, but knowing, every single size of every single section and where it changes and every little bend it makes, in X, Y, and Z really wasn't all that value, of that much value. Our facilities guys want to know, okay, if there's a problem with one of these vents, where is it connected up to the main line, and what else is affected beyond that? And so this allows us to do that without a lot of the overhead of trying to maintain BIM. We can also do some interesting 2D and schematic 3D. We're not quite ready for realistic 3D yet. We're working on trying to put together a 3D campus that would have correct topology for the campus, as well as actual elevations for the individual floors. But for looking at this kind of scale, most of the time it doesn't really matter if you're just trying to analyze what's there. If you're trying to do like line of sight sort of stuff, then yeah, it's definitely going to be important. But we can do a lot with what we already have. And this is just assigning a schematic elevation by floor to each building and floor. And we can do some really cool stuff. The building down here at the bottom is actually 3 separate buildings, which means that there's 3 separate sets of CAD files for each building. But GIS puts it all together, and it looks like it's one seamless thing, which is actually how it feels when you're in the field as well. So that's something else that BIM would have some issues with, is combining large things, especially looking at like our health sciences and medical center complex down here. There's absolutely no way I could think of that Revit would ever be able to make one model for that. So what's next? So our version 2 of our system was primarily focused on fixing the problems of support based on the old system. So it was really getting the floor plans into the system in an automated way. And what we found was when we started looking at the utilization, there was actually a lot of stuff missing. In order to do a lot of things like rotate the floor plan back to where we want it, because facilities doesn't like looking at geo-reference floor plans. They want it like it was in CAD. We had to come up with a way to figure out the rotation angles to get it back. How do you apply that? How do you automate that? So there's actually quite a few supporting pieces of data that are needed in order to make that truly useful. Otherwise, you're kind of left with, well, do a bunch of definition queries, and it's going to be really, really painful. So we definitely have a lot of stuff to do with that, and I'm hoping to get started with that very soon. We've done a wayfinding project. We actually put together a custom interior space routing prototype, looking at 3 buildings on campus and how you could route from room to room across campus, being able to take into account, security, doors, hours of operation, and a lot of that other stuff. And what we came up with was actually a very, very simple process that is also CAD based. So as the CAD people are updating the floor plan, they're also updating essentially the street network on the floor plan, which is just a line down the hallway and maybe a point or a block or something at the doorway. And that really gets you everything you need to do for routing, which is interesting. We definitely want to support more mobile devices. There's a lot that we're doing with the desktop stuff, but mobile is definitely the way to go. I don't have a lot of mobile experience, so I'm trying to figure out how to make all that work. Just getting the word out. I think we have an interesting solution and a fairly usable solution. Just trying to get the word out to other universities and other institutions, as well as other departments within the university that don't even know that this infrastructure is available to do stuff. It's a great tool on the back end, but if nobody uses it, it's not a lot of value. Right now, we're actually doing some crowdsourcing with the floor plans, and if there is a problem with a floor plan, anybody in the university can actually request a change to that, and so it is truly crowdsourced. It's a one-way sort of thing, so they can put something in, but they can't change it after that. And then once they put that in, we get a notification, and then we'll go and assess it and figure out if something actually needs to be done or not. But there's a huge resource of students on campus that could do all kinds of great stuff, and we just need to tap into it, I think. So we're also in the process of getting a pilot license for Envision from Penn Bay, which is really nice. It would allow us to do a lot of the stuff that we do in a desktop environment with asset management on a web platform. And they've even got some solutions with mobile and all kinds of other stuff that I haven't even gotten into yet. So I'm really excited about that, and hope to have that up and running soon. And of course, more. When we did the routing project, we started to look at things like, well, what if we had information about the locks on the doors, and could we bring in the lock shops so they manage the locks? Then what if we did, linking up to hours of operations, and that really started to build to a point where not each individual component had its own value, but once you got to a certain level that all the other data was being maintained, you actually had an economy of scale that really made some amazing things possible. An example would be somebody needs to get directions to the classroom or something like that, and they're on their mobile phone, they have to log in, so the system knows who they are, and the lock shop knows who has what keys or access to which doors through the automated security system. It knows the hours of operations, and it can route you according to your level of security or the operational hours of the building or anything like that. But without having those other components there, you're limited to, well, here's your route. If you hit a blockage along the way, sorry, you're on your own. So there's individual components that have value, but it's also aggregating everything together and merging all that data in a processed way that allows you to do things above and beyond, things that we even thought possible. So real quick, and I definitely want to leave a lot of time open for questions, and I'm just about done. This is a look at our routing project, and so you can see the upper picture is the actual street network that's necessary to make it work. And I'm not sure if you can see the little spheres that are on there, but the spheres are the doors. Those are the stops on the routes, and we actually do route to the doors, not just to the closest point in the hallway to the center of the room, because that doesn't really have anything to do with how you access a room. And in the bottom, we actually did a sample route and just picked 2 points and let it calculate how to get there, and it did it. Like I said, we've done some preliminary work with Envision, and so far everything looks really, really good and really easy to transfer what we have into Envision interface. So hopefully we'll have that up soon, and maybe be able to show some more about that. So with that, I wanted to leave a lot of time open for Q&A, and I think we have almost 20 minutes or so. So Scott, I'm not sure if you want to moderate questions, or how do you want to do that?
Well, we can do it. The only way we can have them do it is through the chat window right now. And it looks like the first question is, how large is the UW portfolio square foot of buildings?
Sure. The total square footage, and I haven't calculated this recently, but I want to say it's somewhere in the range of 22 million square feet. Of that, we have, in the last calculation, about 20 million square feet of that in CAD. So we are missing some stuff, but it's a lot of the really small stuff, really random stuff. Might be a little shack here and there. I know we have a field station that has like, 30 buildings or so, and I think we only have like 3, but each building is maybe a couple hundred square feet. So.
I also have a question from Jose at USC. It says, for wayfinding, do you do the topology in AutoCAD?
No, that is handled by GIS.
Got one from Columbia. It says, how long did it take to prepare the CAD drawings?
When we went from version 1 to version 2, I think we probably spent almost a year on just cleaning up the drawings and getting everything converted over. That was probably the biggest part of the whole thing, was making sure that we had really good, clean, standardized CAD drawings. Because without that, it's nearly impossible to do any sort of automation. There's too many variables unless you have some standards in place.
Got another question.
Hopefully that's what you were asking about.
Got another question from Brian Blasser.
Yeah.
Where does the object ID come from? ArcGIS, AutoCAD, map?
The object ID. And I think I know where you're going with this. In order to do a sort of a change detection of, did this room actually change? Is this still the same room that it used to be? You would need to have some sort of stabilized object identifier that you could check against. And we don't do any of that. We actually just base it off of the unique room number. And the reason why we do that is, for one, it alleviates a need for a fairly painful and sophisticated integration with a database inside of CAD, which I don't particularly like. I know some systems use that and they work fairly well, but you really have to be much more careful, and you really have to know exactly what you're doing when you do something with a live link database. If you don't, you could very easily wipe out a lot of data in your database accidentally. And CAD is a very dynamic environment, and that's the way CAD people use it. It is very dynamic. When you start to put a constraint of, this is a specific thing that's linked to a database, and if I do something in CAD, it's going to affect something in the database. You lose a lot of that flexibility, and the people doing CAD really have to know exactly how all that works. We've chosen not to do that. We use a lot of student help with that, and just the training alone on trying to keep somebody up to date on how that sort of system would work is kind of cost prohibitive. And our space data is actually entirely separated from the floor plan. So there is a one-way push that the CAD drawings define what rooms exist, but after a floor plan is updated, there's a look at the space data, and the space data is updated accordingly to match the CAD data, but it's not a fully automated process. So we're not deleting data out of the space management system just by updating the CAD drawing. Hopefully that's what you're looking for. Aside from that, the global unique ID for a room, for our purposes, is basically the building number, the floor number, and the room number concatenated together, and that is done in CAD.
Another question from Bill says, when checking AutoCAD drawings, what kind of errors are you looking for?
So we look for unique room numbers. Room numbers have to be unique because that actually defines part of our unique identifier for any given room. But because we don't have all the floors or all the rooms of an entire building in one CAD drawing, we can only check against the one floor, which is why our floor number is part of our unique identifier, because we can only check for uniqueness within the data set that we have, and in our case, it's a CAD file. So we look for unique room numbers there, which make sure that our unique identifiers are unique as well. We look for a one-to-one relationship between the room number and the room boundary. We shouldn't have a room number, at least not like a true room number that doesn't have a room boundary. We may have a room number as text that shows like a room number above or below, but it's not actually the same block as our real room number. So the system doesn't try and assume that should have a room boundary. We make sure that all the polylines are closed, because if they're not closed, they're not a polygon in GIS, so it does have to do that. Trying to think of what else there is. I know there's more. It handles pretty much anything we can throw at it. I think I'll leave it at that for now.
Robert had a question. Do you use GIS tools to process reports on IDC contracts and grants information? And sorry, it moved on the screen. Contracts and grants utilizing GIS as a middleware for processing tabular data for campus strategic planning.
I believe that's indirect cost recovery, and the indirect cost recovery is a huge driver in what we do. Everything that they do with space utilization and functional use and that kind of stuff all comes from the space management system, which is driven by the CAD system and CAD and GIS system. I don't work directly with them on analysis or anything like that, so I couldn't answer that. And there's a different department that does planning. I'm not part of the planning department, but I know that they do some campus level planning and building planning and room planning sort of stuff with GIS.
We had another question. In your campus routing, do you account for going between floors or levels?
Yes. Yes, that was probably the biggest challenge. And we actually came up with an interesting solution in that, and it's actually all done in CAD. We have the vertical information as data, so we don't actually draw anything in 3D in CAD. It's all 2D data, and then so like a line for a stair has a from and a to elevation as an attribute value. So when the translation process happens, it creates a three-dimensional route based on that elevation, but it's actually 2D with data in CAD. And then an elevator is basically a point, or actually it's a line with the same start and end point. And again, it has to and from data as well.
Another question from Jim. He wanted to know if you could touch on the check-in and check-out process within CAD.
Yeah. Is there, I guess, anything specific about the check-in, check-out? I can show you exactly what that looks like here, in fact. So we use Autodesk Vault, and nice thing about being run by Autodesk is it integrates real nice into AutoCAD. And so there's a Vault ribbon, and it's really just a matter of open from Vault. It will open a window that looks very similar to your standard open or file browser window, but it's actually looking only at the Vault itself. You're not able to see your C drive or any other drives. It's just the Vault itself. And it's just a matter of navigating to the drawing you want and opening it up. When I rebuild some indexes or something on my database, when I open one up, it'll ask me if I want to check it out or not. And in this case, I don't want to check it out. I just want to open up and look at it. And so there's the drawing. If I do have it checked out, then there's a check-in. Also, when I close it, it'll ask me if I want to check in my changes. There's also an independent life cycle state beyond whether it's checked in or out. So I can go and say, for example, change state, and I did change state. There's change state. So I can change this from a release drawing to a work in progress. Oh, I can't do that. I don't know. Well, apparently I need to look at that. It should give me an option to change it to work in progress first. So I can do that in CAD as well. So I can change it to work in progress as soon as I check it out. And so when I check it back in, it's still work in progress. And it's only after I say change state and change it to released again, that release status is what triggers the server to know that it's able to be downloaded. Otherwise, we can still check in changes, and it won't affect GIS until the state is actually changed to released. Hopefully that's what you're looking for.
Got another question from Columbia University. How many staff are in your team with this project so far, and how many manage the migration?
Well, there's me. Right now, I don't actually have any other staffing. Permanent staffing. I have 2 temporary drafters that do pretty much all of the floor plan changes. We do have 1 additional person that is responsible for project document reviews. Being we're part of the Capital Projects Office. We manage the standards for all projects. So when an architect submits drawings, especially the record drawings, we review those and make sure that they adhere to our standard. And that is a huge component that feeds into our floor plan updating. So if we don't have that in place, if we don't have good, clean stuff coming from the architects and engineers, it's going to be nearly impossible to incorporate into the floor plan. So having that 1 position to do the standard management has been really critical. Beyond that, like I said, I have 2 temporary drafters, and I have 1 temporary GIS admin that's part-time, trying to help out with some database stuff on GIS. So unfortunately, not much.
Got another question from Jose. Do you know if ESRI is developing anything to be able to work with Revit models in their data?
I don't know that ESRI is. I know that FME has been working on that. I haven't had a chance to check in recently with them. But their goal, right now they do have an IFC converter. So if you export your Revit model to IFC, then you can do a translation to GIS. I've had limited success with that only because the quality of the translation depends so highly upon the quality of the model. We really need to reassess our standards for Revit to prepare it for GIS. There's just too many variables in the way you can do things in Revit with the different families and everything. What we do right now is we actually use CAD as an interim translator. So we'll export the sheets from Revit into CAD, and then the CAD translates into GIS quite well. But it's that direct Revit to GIS is challenging, especially without losing anything. But I'm hoping that FME will have something hopefully soon, and we'll be able to work with that.
Mary Jo had a question. What is the purpose of linking the polyline to the attributes, and what do you do with it after it is linked?
Well, twofold. The link, from a pure CAD perspective, whether you're doing GIS or not, I highly recommend using a field for your square footage text, just because it makes it so you don't have to type it in. So if I go in here and here's my field thing, and I can go and select my object, and it'll do whatever. If I change my room boundary, not a very good polyline. So it's 115 and regen, it'll automatically update my square footage text. So that's one of the huge things for us, is we never have to worry about updating the text for the square footage. It's just always there. It's always right. It's impossible for it to be wrong. From a GIS perspective, that link allows us to take all the data that we have in the block and transfer that from the block, what do they do, into the polyline. So, you know, all the information we have in our room block, and I mean, you can really go crazy with this. You can put whatever you want in here. That allows us to, actually, I don't have Arcgis AutoCAD loaded, so I will save and load it. Yeah. So that automatically transferred all the data from the block onto my polyline. So when I look at this from GIS, the feature class and every feature in that feature class has the data already assigned. So I don't have to do any sort of spatial intersection to try and get the data from the text block onto the polyline, which is what we actually want.
Okay, we had another question from Columbia University. Do you have quality control administrators dedicated to checking drawings, reports, and etc., or do you call them something else?
Short answer, no. Not really. At this point, we're not really even funded to be able to do what we are doing. The quality control right now is kind of done manually by me on a irregular basis. You know, I'll go in and make sure that you know, all the floor plans that should be in the system are in the system, and that kind of thing. There's also our space management system that reads the GIS floor plans and integrates that and merges that into their own application, and so they actually provide another set of eyes. So if they do see something wrong, they'll let us know, and then we can come back and fix it. But we don't really have any sort of dedicated quality control.
Jim had a question. Are there any campuses in California using this currently that you know
of? I don't think we have any campuses in California. I'm not sure if anybody in California that's doing. Actually, I just talked to Caltech recently, and they worked with Steve Grisey as well as their CAFM person, and put together a solution that was somewhat similar to this. So I believe Caltech might be the people to talk to.
Hey, Columbia University.
I can't remember.
Sorry.
Sorry.
Go ahead.
I can't remember who it was I was talking to off the top of my head from Caltech. So.
Columbia had another question. Is there a separate group for planning, assigning room numbers, surveying, move management? Who does all that for UW?
Planning, yes. There's a planning and budgeting department, which is on the provost side of the university. capital projects is on the vice president side, so the facility side of the university. We essentially execute the plans of planning and budgeting for the most part. We actually do room numbering ourselves because since we're so involved with the projects, it really ended up that the only way to make sure that the room numbering reviews were getting done consistently was to really make it part of the project process. And so that's actually one of the things that I do myself. So I work with all the projects and do room numbering. Surveying. When talking about the inside of a building, we really don't do any surveying at all. I mean, we'll do some field verification and measurements, but for exterior, outside the buildings, that's all facilities, campus engineering, and they do a lot of surveying on campus. Move management is handled, I don't think there is really any one group that does move management. Some departments will use our design services group, which is part of capital projects, to handle some move management for them. I think some other ones do their own move management. I don't think there is, I'm sure there is no sort of central move management system for the UW.
And another question from Robert here. Is your campus space inventory managed out of your planning office, not by you?
Correct. It is done as part of the planning department.
Okay.
And that's actually where the first version of the GIS floor plans came from, was truly to support the space management system. And I think I started over there in 2002 or 2003. And so we put together that at that time. And about 6 or 7 years ago, I left that department and went out in the world, and then ended up coming back, but came back to the capital projects office. And they didn't really have the staffing to handle the CAD side of things, so they had asked CPO to work on that, and that was one of the reasons why they decided to bring me in, was to work on that. So we're now handling the CAD side for planning and budgeting.
And another a follow-up from Jim's question. Are there any campuses that you know of using your method?
Not directly, no. Unfortunately, the way we've built the code in CAD and most of the rest of it is kind of hard-coded to our schema. With our next version, we are planning on trying to make this much more modular and configurable, so it could be used by others a lot easier. And I think Steve Grisey with Vertex 3 has been working on a new tool called Gizinta, Gizinta, which is a data transformation toolbox, essentially. And I think he actually has some examples of doing floor plan translation. And so I'm going to be working with him on trying to get what we're doing incorporated into that a little bit more. It's still kind of a starting point because everyone's schema is going to be different and everyone's going to have different needs. So it's really hard to make one tool that will just do everything without forcing everyone to change the way they're doing things.
Hey, Joe had a comment. She says, I've linked the polyline to my square foot field. I don't understand how it is linked to the room number. I don't know if you can...
So the way the room number gets transferred to the polyline is the custom code that I wrote in Lisp that actually transfers the data. It also deletes and recreates the entire Arcgis for AutoCAD feature class. So it's custom programming using the Arcgis for AutoCAD plugin that allows us to see the data as well as transfer the data. So here's my feature class in CAD for the rooms, and this is the definition of the feature class. Essentially, it's a polygon type. It has a layer filter on it, so it's only going to give me my room boundary polylines. And then here's the fields that I need and the data type. And if there's any default value, I can assign that. But that's all done automated as part of a script that's run. And that's actually run every time the CAD user hits save. So if I can actually change this one, for example, I'll say, well, it's not actually 205, it's 205. And I don't think I have the right update for Arcgis for AutoCAD. There's a bug with this. So it did actually change the data, but it's not showing it. When I hit save, it should rebuild it. So it doesn't matter what I try and put in manually. The script will override the user every time. And so if I want to change the room number, I actually come in and change the room number here. And if I hit save again, they'll run my script. I now have the right data. So it's a custom script that does that.
All right, I guess we have another question from Bill. Or I'm sorry, Tiffany. What space management program do you use at UW?
It's custom. It's a homegrown system. It's basically just an Oracle database. The front end for it is also custom that allows the data to be managed through GIS. So selecting a room brings up the room data, and depending on the user's security access, they can go in and change the data, and that writes it back to the Oracle database for space data. There is no way to change like square footage or room number with that because that all comes from CAD. So it's a very one-way process with that.
Another question from Brian. Can this be done with ArcGIS for AutoCAD 250?
Yes. In fact, that is the version that I am using. 300 does not work. And I think I saw there was a new one out. The problem is that the API is not the same with anything beyond 250. It used to be that there were predefined functions for like create feature class, and you feed it a bunch of information in Lisp, and it would create the feature class through Lisp code. The way they're doing it now is they're basically exposing how they're telling the system to create that feature class, and it's up to the user to write all the code to create that feature class. So unfortunately, it's going to require me to rewrite some of the code that I have, or at least recreate those custom functions that ESRI was doing before.
Will you be posting on how to create world files in AutoCAD in the near future, or a simple step-by-step of this webinar?
Yeah, I've got all the CAD stuff done. We're also putting together a couple of Python tools to extract the rotation and what you can do with that. Once that's all done, then we'll package it all up and post it up on the ESRI website, and I'll make sure I do some sort of a posting on like the CFTA Facebook page or something like that as well.
Okay, great. I think we're just about out of time, so
Okay.
yeah, actually I think we're over a little bit. But I would like to thank you, Aaron, for this presentation. I think it's great. Just for the people who are still on, next month we're going to be doing part 2 of a more in-depth look at GIS at UW. It's going to be on June 20th, so we're looking forward to hearing from you then, Aaron. But we will be posting.
And also I would, I'm sorry, I just want to say I am definitely interested in getting some feedback on what people are interested in seeing. So more about the world file creation. I can definitely include that. So if people have more specific topics that they'd like to see, this was definitely a very high-level overview. I could spend a week talking about probably any one slide, so I can tailor to whatever people are looking for. So.
Okay, great. All right, with that, I think that ends our presentation for today. So we will be posting the material on the CFTA website for download, and we will also be posting a recording of the presentation online for viewing. So look for the links on our website soon on where you can find this information. I would also, again, like to say thank you to Aaron Cheuvront from the University of Washington for his presentation on the University of Washington's GIS interior space mapping. With that, that concludes our seminar, and I thank everyone for attending today. Thank you, and we'll see you next month for part 2. Thanks, Aaron.